Good morning, everyone. and welcome to the day 2 of this FDP. So, without much further ado, let's start with our today's agenda. Let me clear the today's agenda. We will be having 3 sessions. So, at the first session, we'll be looking at how we can integrate some circuits or development board and sensors on a uh, simulator, and we can achieve some kind of applications over there. But let me clear you one thing. Simulators are not equipped with all the sensors and modules what we are going to use in this series of the sessions later. And we can achieve some kind of application. Arti ma'am, can you please mute your mic? Thank you. So these sensors what we are going to use in this series of sessions, these all sensors are not directly included in those simulator what we will be using. The most trusted simulator is Tinkercad, so we will be practicing on the Tinkercad, but you will be getting some kind of a hands-on, like how we can integrate some circuits with the development board and how exactly that is functioning. So some sensors I'll be taking up, those are available in Tinkercad, like a PIR sensor, passive infrared sensor. So we can create a motion detector kind of application through that. So I'll be demonstrating it on my side, and again I'll be instructing it on Tinkercad as well. So similarly, we will be looking at. So before doing with the Tinkercad simulator, we will be checking with the IoT taxonomy and how exactly the sensors are getting in flow. After that, in the second session, we will be seeing other sensors like card reader or RFID sensors, NFC sensors, because these sensors are nowadays frequently used in various applications. So this today and tomorrow we will be taking up with the all the sensor parts, and as well as we will be taking up with some IoT protocols, and then we will be moving on to create an application, because in these 2 days or 3 days or 3 4 sessions we are having in bits and bytes, like we are taking up a sensor, we are integrating it individually on the development board, and we are seeing the result. So after that, we will be taking up a one automation project where we will be creating a complete structure of a project. So I'll be showing the entire step-by-step process of doing that, and I'll be making that circuit entirely from a scratch on the live session. So that we will be doing. So you will be getting a flavor of how the circuitries are integrated and can be created as an application. Even with that, in today's session, I'll be introducing you with wireless sensors, like Node MCU is having already a wireless sensor, Bluetooth and Wi-Fi. That sensor is already embedded into a Node MCU. So we will be seeing how exactly a Node MCU can be configured to operate your devices or sensors remotely. So that is the most convenient part, and that is actually a justice to the word internet in IoT, Internet of a Things. So that way we will be moving forward in today's session. Right. So as far as the first IoT taxonomy is concerned, then we are having this stack layer. So first is a perception layer, then we will be following that with the processing, we'll be again following that with communication, then middleware, and then application layer as such. And by doing the application layer, it means what? In the perception layers, we are responsible to collect various data from our sensors. Like for example, in the last session we use flame sensor. So that flame sensor is detecting a heat, and according to the tolerance what we have setted, or according to the sensitivity. Now, what is a tolerance and what is a sensitivity? Can anyone tell me what is a tolerance and what is a sensitivity in a context of flame detection, so in context of a flame sensor? Yes, anyone? What will be the tolerance of a sensor and what will be the sensitivity of a sensor? Okay. Uh, Tolerance means what? Tolerance means how exactly sensor is behaving in a certain condition. Like we have a threshold ratio. So threshold ratio means what? We are having some kind of a upper level and a lower level. So if the sensor data or sensor is sensing a information or a data, it is collecting a data which is below that average point, it means that it is having a low tolerance. And if it is sensing that data above that threshold ratio, which means it is having a high tolerance. Now tolerance in the case of sensor is what? It is a amount of or the degree of data which it is collecting, and accordingly it is giving instruction to the another connected sensor or another connected circuit to display something or to have something happen, like that. That is the tolerance. And secondly, the sensitivity. Sensitivity, it means what? How exactly the sensor is reacting on a certain situation. That is what the sensitivity is. So if we set the sensitivity to a very low, then what will happen is, in case of a flame detection, if there is a flame or there is some kind of a fire happening, but lack of sensitivity or sensitivity is being low, it is not detecting it because needs to be in a very near proximity. By having some degree of a distance, it will not going to detect a fire. But if we are setting it the sensitivity to a very high, then what will happen is a slightest change in a current environment, like in which that sensor is deployed, in slightest changes in that current environment, and if it is getting a warmness, then it will automatically trigger itself. So like yesterday when we are dealing with the sensor, I've switched off I've flown the flame, and after that some kind of a warmness was there at the stick, though the sensor is reacting to it. Why? Because I have set the sensitivity to a very high level with the potentiometer which is there on the sensor. So we need to set our sensor in a very not below average and not above average. So we need to deal with the tolerance and sensitivity in a simultaneous way. Now the best way to do this is, we can calibrate our sensor in a such a manner that it will give us a proper result. So every time we need to calibrate our sensor. So that what's the perception layer is all about. So perception layer is all about to calibrating your sensors, calibrating your models for collecting collection of a different types of information, different types of data from the environment where it have deployed. Then these sensors are very small in the size. Even these are very cost effective, and it consumes a very low energy. Like the um, flame sensor, if we take, then it is taking a 5 volt of input, and actually in a 5 volt it is only taking up a 1 or 2 volt for operating on that. Other volts or 3 volts which is remaining are for the reserve purpose. So if it is not functioning very well or it requires a drag of electricity, then it will be utilizing that current. So that is what these small sensors are all about. So these are very low power consumption category sensors. Then these sensors are used in various applications like PIR sensor, flame sensor. So these are very widely used. So what kind of a sensor data or sensors we can have in our day-to-day life? What we can see, like the IR sensor, the normal remote control IR sensor, we can see flame sensor, then motion detectors. Then we are having a temperature sensor, and lot of things are there around us which are actually on the perception layer. So if you are having a AC at your home, then you are having potentially three sensors in it. First sensor is with the remote, that the IR sensor. Second one is a temperature sensor which is installed at the LCD panel of your AC to conduct the regulation of the temperature. Like that temperature sensor is a bi-directional temperature sensor. Means what is a bi-directional temperature sensor? That bi-directional temperature sensor means it will detect a temperature outside the environment, means outside your home, the normal temperature what it is, and accordingly it will going to set the temperature on the AC. So if you set that AC on a auto mode, then this kind of a bidirectional thing is going to happen. And once the desired temperature of the AC is reached, then automatically it sends a signal to a switch relay. Then there is again a sensor, or that is not a sensor actually, that is a module, that is a relay module. So there is a relay which will switch off the AC for a moment. Once that temperature is started increasing, so if you set your AC to a 23 degree, till 23 degree it is reaching, it is getting increased in the temperature, means the temperature is getting low. And once it is stable on a 23, automatically internal unit of the AC is switched off. And once the temperature is started rising, and if it is crossing a threshold of the temperature sensor, immediately that temperature sensor will send a signal to relay to switch on the AC. So this is what this is a regular consumption of IoT device what we are seeing every day. And the same principle is applied to industrial works as well. So if you visit any of the industry where big machineries are implanted, maybe in automotive industry, in heavy metal industry, so there are mechanical instruments which are automated. So these automated machines, or take example of packaging machines. So if we are having a bottle packaging plant, and when we visit a bottle packaging plant, there is a big machinery which is collecting some bottles, then they are filling it with the whatever the liquid or any kind of a product they are having. Then it is going on to another unit. That unit is tightening up the seal, and then the final product is going for the packaging. So if you look at the that machine very closely, so there are various sensors which are embedded. There is a conveyor belt which is taking up the bottle. That on the conveyor belt there is a weight sensor which is sensing a weight of that bottle. Accordingly, the filaments or whatever the product is there, that will be filled in that bottle. So then there is a flow meter and the flow sensor. If it is a liquid product, then there is a flow meter which is installed at the at the nozzle point of that filler, which is measuring how much that liquid or the liquid product is poured into the that bottle. So once it is reaches to the number what is set it, maybe 200 ml, 300 ml, 20 ml, 10 ml, zero point 0.5 ml. So if we are talking about the medicines, then medicine comes from the point 10 ml, zero point 0.5 ml, then 10 ml, like that. So once you are having that flow which is detected, it automatically stops in fill. And then it checks for the weight with the weight sensor, and then it goes for the second station for tightening up the lead. So again, that there is a IR sensor and visual IR sensors which are examining that bottle lead, whether that bottle is already packed with the lead or not. Now if that bottle is not packed with the lead, then the lead is flowed on it, and then again another machine will be tightening it up. And then it flows again, it will be checked for a quantity and the quality using some visual inspector sensors, not the sessions, sorry, sensors. So these sensors are responsible for taking up the right amount of a product. If that bottle shape is not proper, or that bottle is not properly packed, or the product is not properly filled, maybe it is overflowing or it is not at the mark, then automatically that bottle is getting rejected. So there is a visual sensor. Now these visual sensors are working with the cameras. So the no ESP32 cam we see yesterday, that kind of a sensor in a small prototype we can use to create or to mimic this process. So like this, the sensors what we are dealing in this sessions, these are a very small sensors which are we can use to create some small prototype. But based on these prototypes, if these prototypes are working very fantastically, then you can get the industrial sensors, or you can manufacture your own sensor and can manufacture your own PCB and can create a good product out of it. So environmental sensor, medical sensors, chemical sensor. The medical sensor example we saw yesterday only, that we have a ECG sensor, we have a pulse meter, we have oximeter, we have a oxidize meter. Then we can even get the sugar level testing machine. We can get ultrasound sensor. So all these sensors are into a medical sector, where we can create a health management product. We can create it with that way. So we will be having a chemical or biosensor, like the smoke detectors what we were having. So the MQ series of the sensors. So those MQ series of sensors are responsible for measuring what kind of a substance are there in the air. Maybe it is a carbon molecule, non-carbon molecule. What kind of things are there depending upon the application of the sensor. So if we take a MQ2 sensor that is responsible for carbon monoxide and the carbon dioxide kind of gases to sense, then it can sense that gas, and even with the help of microcontroller we can program this sensor in a that way that it can measure what kind of a density that molecule is having. So we can sense that in this my home, what is the amount of carbon dioxide is in my house. So in whatever the air I'm breathing, what yeah, how many amount of oxygen I'm having, what type of oxygen is left. So if we take this kind of a sensors in an industrial manner, then we can have implementation in medical field. We can check if the patient is on a ventilator, or it is that patient is on oxygen, then how much oxygen is passed on to that customer, not the customer, sorry, to that patient, because patient is a customer for hospitals. And I'm used to with these wordings, because again we are dealing with various hospitals for doing their pen test and all. But still, uh, these patients, so how much amount of, or how much cubic oxygen or kilo oxygen, so that measures in kilo liquid oxygen. So how much kilo oxygen is given, or the liter oxygen is given to the patient, and then what is the ratio of carbon dioxide emission. So all these kind of things we can actually create, or that particular product we can create which can deal with this. uh, Even if we take it very further, this kind of a sensors are very useful in space missions, where we wanted to check whatever the space module we are having, how much oxygen is left in that module for possibly breathing for the air crew or the space crew. What type of other gases are there? Maybe a emission of the regular stuffs, uh, hydrogen, hydroxide, than your carbon dioxide, and other any gases are there. So these kind of things we can actually check it out. So perception layer is responsible for getting all these kind of what we can say, data. Then the most importantly here, it is infrared sensor, RFID, and mobile sensors. So if you can see the RFID, nowadays everyone is used to tap and pay. So that is what, that is the advancement in RFID. So RFID is a radio frequency identification, and the ID, or what we can see. And in that radio frequency, with the near proximity, we can actually send and receive data, and we can have authentication protocol installed, and we can authenticate the legitimate information on that. So similarly for similarly NFC is working, because it is based on the RFID technology, what I have observed. But if you can see in RFID, every communication between your node, means the machine, and your other machine, is not encrypted. It is what, it is a clear text transmission. So if it is a clear text transmission which is being used in the financial industry, then it is a very dangerous thing, that it can be stolen, it can be hijacked, it can be hacked. And definitely by doing the cloning and all, financial loss can be there. So they invented a new technology called NFC, which is having a more security feature. Like NFC is having a security layer embedded on the RFID, which can encrypt the transaction, or which can encrypt the communication. Maybe that communication is belongs to the financial transactions, or it can be a general transaction like swipe in swipe out kind of a transaction. Like in your college also you used to give a thumb, that is a biometric, but instead of that you can have a RFID card or you can have a NFC card. So in this situation of the COVID, we can save ourselves from touching that device every time, right? So we can use our personalized cards. So that is the RFID or NFC, which is all commonly we are using. Even with our debit card and credit card nowadays, NFC enabled cards are there. So I'll be taking up that practical too. I'm having a RFID and NFC reader, so we'll be checking up that how exactly these things are getting inserted, and how these cards are getting read and write. So that we will be doing it. Then we will be having a mobile sensor. So in our letter of the session, we will be taking up the what exactly a 5G and the relation of the 5G with the IoT, and how 5G or 4G, even the 4G LTE protocol we are talking about, how the LTE is carrier, good a carrier for your secure mobility and secure IoT mobility. So machine to machine communication, we will be taking up on that. So that was the perception layer. After the perception layer, whatever the data we have collected, we will be pushing that data onto a pre-processing layer. Now what is this pre-processing layer? Pre-processing layer is taking out the data and filtering it out. So we can have our different types of services installed on some machine. So we will be taking up the data from sensor and we are putting it on somewhere, maybe on a cloud. We can have a network gateway, we can have any device. So if you can see the illustration over here, the stack over here, we are having a smart devices like smart TV, washing machine, fridge, car, locks, or the smart buildings we can have. Nowadays we are having smart cities. So these all are emitting some kind of a data. So that data will be captured on a smart gateways. So there are specific gateways which are created for IoT devices. Those gateways are called as a IoT gateway. So the that is the networking instrument which is specially tuned for these kind of a data, specially tuned for these kind of a sensor accumulation and accommodation. And that network device is actually communicating with sensor all the time and the module all the time. Then we can have a real-time analysis done on that smart gateway. So our data visualization tools in the machine learning we can install on there. Even with the real-time analysis, we can install our cybersecurity tools for getting the updates, whether the sensor is providing proper information or not, or the sensor is what we can say, that sensor is rooted, or that sensor is hijacked in some another way where it is emitting some false positive data. So that all things we can do. Then we can have, of course, the filtering mechanism to filter out the data, and we can create a data stack of it or data set of it. Then we can have a storage to allocate it. So we can have storage inline and offline. So inline means what? It can be a online storage, cloud storage or something, or we can have a offline storage where we are having a server and we are taking the backup on that server. So that way this pre-processing layer is working, which is responsible for reanalyzing the data. Whatever the data perception layer have collected, it is analyzing it and creating it for the further processing. That is a pre-processed layer. After that, after the pre-processing, so again the pre-processing is having some limitations of processing everything in cloud. So mobility, reliability, so there are some features and there are some limitations as well. Then after that, communication is going to be established. So it can be NFC, that is near field communication. It can be a RFID or WSN. It can be a wireless sensor networks. It can be a GPON networks. It can be general ISP communication. It can be a low power technology communication. Means the low power technology means if we are having a limited Wi-Fi adapter, like that Wi-Fi can be emit the signal up to 100 meters only. We can have a Bluetooth which can emit signals up to 200 meters or 10 meters, 20 meters. We can limit that way. Or we can have a Zigbee which is having a 1.2 megahertz of a signal processing power. So it is having what these are the low power technologies. So these are wireless technologies or communication technologies which are consuming very low power and providing a very good results. that everything comes under the communication. So whatever the data we are collecting, processing, that has to be communicated in some another way. So the processing, so the communication processing is very important in this way. Then we will be having a middleware. Now what is a middleware? So we will be taking up the cloud architecture for IoT, and we will be creating a one cloud application which can control our small prototype what we will be going to create in our session. So in that way we are dealing with the middleware. So here the cloud service provider is your middleware, which can give you a application to connect with your device and device to the application both way. Because sometime it happens like your application is getting connected to device, but device is not getting connected to application. Now what is this scenario? You will be saying that that is one of the same thing. No, that is not the same thing. One is the situation where your application is getting connected to the device. So for example, if I'm having a AWS cloud for the IoT services, and I'm having raindrop sensor, suppose. So I'm having a raindrop sensor. So when that sensor is activated, that's supposed to send some data. And if the first situation is there, only cloud is connected to the device, then what will happen is whatever the instruction we flow from the cloud application, that will be received to the sensor, but sensor will work on it. But whatever the data sensor is emitting, that is not going to be captured by cloud, because sensor is not connected to the cloud. So this needs to be resolved with the bi-directional REST APIs, or REST or the APIs. So we need to integrate our application in that sense, that it can have back and forth compatibility. So middleware is basically equipped with all kinds of application, database, semantics, event, services, connections, network, all the parts what we wanted to connect with our application, and we can control our application remotely. That we can do, right? So that is the thing. Now I'm having a very good example of a middleware with me. I'll just turned on my camera. Okay, is my camera visible to all?
Yes, sir.
Yes, sir.
Okay, so this is a drone what we have created. So this is a DIY drone. So this drone is made up by us, by me actually. So it is having a lot of components. So I'll be taking up the components very soon. But the main part with the connectivity or the communication or the middleware we are talking about. So it is having a telemetry device over here. So this is a telemetry. So the what telemetry device will do? Telemetry device will connect the drone with the ground station. So this is a air module, and I'll be having a ground module which will be connected to my mobile with the OTG cable. So that ground module will be continuously synced with my air module, and the entire operation of this uh, quadcopter or a drone will be controlled by my application. So you can use already created application like a tower, or we can have a G ground control. So all these applications are already created. Even if we wanted to create an application, we can create it, as Android is open source. So through Android application we can control this drone. So I'm having a flight controller over here. I'm having a AGPIT 2.8 flight controller with the GPS. So I can lock on to the GPS. Even I can send a signal to my drone on the fly to change its trajectory, to change its position, to change its completely a flight plan. I can give a condition like it is on a flight plan, like I'm having a GPS sensor, so I can program this drone for a certain height, and I can have various applications like this drone we have created for specifically for one of the POC what we are doing. Like we are doing it for the medicine. So we will be having a one medicine box over here, and it will be having a lock and the QR code display. So there will be a small display like the display which I have shown you, but that will be a color display. That one is black and white. And once we receive a kind of a emergency order that we wanted to have this kind of medicines to be delivered, then this drone will be programmed for that fly path. This drone will be flight, and then once it is reached to the destination, it will be lower on the ground, it will be safely land. Then we will be embedding a one small camera over here to see the ground space, and once a landing space is identified, that this drone will be automatically getting landed, and this entirely a process will be a completely autonomous process where no human intervention is there. And once the drone is landed, that time drone will beacon, and that similarly it will send a signal to our application, it have landed successfully at the coordinate. And then we will be sending the message, or the system will send a message to the customer. Once the customer reaches to the drone, it will ask to scan the QR code. Once the drone showed QR code and client have scanned it on the mobile application, if both are authenticated, door for that package box will be opened and can take out the medicines. So that was the idea about it. But why I'm showing this right now, because I wanted to clarify the middleware section where we are having a mobile application which is directly hosted on a AWS for a cloud services. So that mobile application is a client mobile application. Even we are logging in as an administrator in it, but it is a client application. And another application is for controlling this drone. Again, that instruction is also flowed by the cloud. So this telemetry is connected to that. Now, no, this telemetry is connected to a mobile phone. Even we will be having one. Uh, we will be having a one internet module which can be get connected using a GPS to the internet clouds. So we will be having a better synchronization with the tool. So uh, there we can implement our various sensors. Right. So that is what actually the middleware section is. Right. Right. So are we clear till this point? Any question? Any doubt?
No, sir.
Okay, great. Thank you. So once we say the application, we can have energy conservation, smart transport, social life entertainment, supply chain, smart agriculture, health and fitness, smart environment, home automation. Means almost all the areas where we are seeing ourselves, there we can implement IoT, and we can put abbreviation like smart energy conversation, smart supply chain logistics. Now, once we talk about supply chain logistics, supply chain is a very big industry. So if you wanted to manage your entire supplies, manage your warehouse, then we can use IoT in that way. Even if you are ordering something through Amazon, Amazon is having a very good tracking of the package, or a very good tracking system. Now, how they are able to capture that kind of accuracy? Why? Because of the technology and the IoT instrumentations. Like they are having scanners, they are having QR code printers, they are having a good GPS locators, they are having a good scanning mechanisms, they are having a good stacking of the things. Even they are having a stack rooms where they are managing that stack room as a smart stack room. So they can manage what kind of products are stored in which category of a stack, and at what level it is stored. Maybe it is of a 30 or 13 or 14 story buildings, and at what level that kind of a product is there. And I don't know about the Indian warehouses, but in some other warehouses in outside India, maybe in California and in Canadian Amazon warehouses, they are having some small robots to place the package and take out the package for delivery. So that is a completely a smart warehousing project what they have already implemented. Even Amazon have started a trial on the smart shopping experience where they are having a shop which is already equipped with lot of sensors. So you need to wear a band, that is a wearable device, and then you need to enter into that shop. Whatever you want, you can take it out, and then you need not to pay upfront to the storekeeper or that cashier. You can take whatever you want, and you just walk away from that store. Automatically that prices will be detected from your Amazon wallet. They have Amazon wallet installed, with different kinds of Amazon wallet. So they're having a variable device which is having a scanner. Then every product, what we hold, that will be scanned through that variable device, and if we put that product in our cart, then it will be applied at the cart. So you can see that product is added into your cart. You can see that physically that cart is filled with that product, and even on your mobile application it will show that the product is added into your cart. And once you walk out from that store, automatically that billing is happened, and that whatever the product you have in that card automatically gets checked out and purchased. So they are having only one store somewhere. I don't know exactly the area, but they are having two. No, not the one. 10, 15 stores they are having, and that is on a POC. That is on a concept note. But still, they are doing it very good way. And even once some of the stores are having a cryptocurrencies transaction. So if you are having Bitcoin, Litecoin as some kind of cryptocurrency, then again those cryptocurrencies can be exchanged. Right. Yeah. So now let's move to the simulator. So this is a thinker card. Uh, I guess a lot of participants are already new this simulator, but those are new to this. You can log into the thinkercard.com. I will show the process. So we will be on the same page. I'll just log it out myself. Usually I don't do with IoT training with the simulator, so please pardon me if I go somewhere else, or something is going wrong with that. Okay, so on the thinkercat.com, you can sign in through your Google account, or you can have a Autodesk account. I'm having a Autodesk account associated with my Gmail. So I'll be logging into that. So once you log in into Thinkercad, you will be automatically placed on the 3D design, as the AutoCAD is specifically for designing purposes. So they are providing it that way. But we are interested into a circuits. So we need to click on the circuit. Once you click on the circuit, there are some snippets where you can actually observe the things, how the simulation works. And those are that was the try circuit, the first panel what is going showing. This is the circuit what I have created, but still the same panel, you can see there is a try circuit. So it will give you some trial tutorial kind of a thing where you can be used to with the uh, simulator. So here, to create our own simulator, just click on create new circuit. Once you click on new create
Sir,
new
your screen
circuit,
is not visible.
sorry.
Hello, sir, screen is not visible.
Oh, screen is not visible. Just a moment.
Yes.
Yeah. Okay. Now it is visible.
Yes.
Yes, yes.
Okay. Great.
Yes.
Okay, I'll log it
Sir,
out.
please start from beginning.
Yes. Yes. I'm doing it. Okay. Once you visit thinkercat.com, just log it out. Mine is saved in cache, so it is not getting logged out. Okay, so this will be your screen. Then if you're not signed up, then click on join now, and you can create your own account over here. So as you all are faculty, so you can click on educators, and you can get on that. But I recommend you to go with the create a personal account, because again educator will require some kind of extra authentication from school, because this is specifically designed for the schools. But still we can use it for our own practice as well. So we can click on create a personal account, and you can create an account, or you can directly log in through the G app. So here what I'll be doing is I'll be directly log into the G app, because I have already created my account through that the same process using Google app. So I'm signing in through G app. Once I signed in into the account, it will take us on a dashboard. So this is a dashboard for us. So specifically, Autodesk is created for designing the stuffs. So it will specifically land you on the 3D designs. So we are not interested right now in creating a 3D design. Later on, when we will be having a 3D printing kind of a session, that time I'll be showing you. Okay, so we are interested in circuits, because we will be creating some IoT illustrations. So click on the circuits. Even code blocks are there where we can see how we can code, and we can practice our coding habits as well. But click on the circuit now for a day, and then you can if you are doing it for the first time, it will show you try circuit panel. So you can click on that try circuit, then it will give you some tutorial. It will give you some pre-created circuits to play with it. So if you wish, you can go and check it out. This one I have already created. So what I'll do is I'll create a new one for you. So click on create new circuit. Once we click on new circuit, we'll land on our circuit dashboard. So on the circuit dashboard, it is somewhat looks like ID only. Only the difference is this is your play area, the mouse where I'm moving. This is your play area. Play area means what? Here you need to drag and drop your components. So this is a component pan, and defaultly it is a basic components. So if you click on all, then it will list all the components what it is having, or what it is what we can say configured for your access. So it is having different types of resistor, capacitor, then we have a polarized capacitor, diode, then we can have linear diode, inductors, then for the input, and it is very properly managed and stacked. So in a general category, these are the normal components. Then for the input type, so for the input type we can have a push button, normal push button. So I'm having a push button right now with me. So here is a small push button, the button what I am having. So similarly the same button it is having. Then we have a potentiometer. Potentiometer we saw just yesterday on our sensor. So there are different types of potentiometer which are available in the market, but it is taking up for one type. And there are again for a different readings, 1 am, 2, 3, 10 kilogram or 10 kilo m, and there are various measurements of it. Then we can have a slider switch, on off switch, photosynthesis, photodiode, ambient and flake sensor, then force sensor, IR resistor or the IR sensor. We are having ultrasonic distance sensor, the same what we saw yesterday. Then we are having ultrasonic distance sensor. Now what is the difference of these two sensors? So if I drag and drop here, and I'll drag and drop this sensor here, so you can see now. So this is what, this is a HCSR04, that the same sensor we integrated with our Arduino yesterday. So this is having 4 pins. One is a VCC. Let me zoom in for you. So this is having VCC, trigger, echo, and ground, the exactly same that what we are having. So even it is having transmitter end and the receiver end, the RT and R, right? The same program what we are using. Now if we go on the here, it is having only, sorry, what I'll do is I'll just bring my mouse, so it is very difficult to control it through laptop mouse pad. Yes, very sorry. Now this one is having only ground. Let me take here. Yeah, it is more convenient. Okay, so it is having ground, 5 volt, and signal. Now this is also ultrasonic sensor. Only the difference is, like yesterday I told you that it is depending upon the frequencies, what type of frequency bird that sensor is emitting, like ultrasonic waves. So this is a general ultrasonic wave which is having a 360 meters of a capacity, and it is a way much better than this, and it is having a very good ping ratio, as the trigger pin is already inside into it, so we need to directly put it onto a signal and we can use it, and it is having a better receiving and transmission capacity. Then here we are having PIR sensor. This is a passive infrared sensor. This is a passive infrared sensor. We can use this passive infrared sensor for creating a motion detectors. The beauty of passive infrared sensors are, even through passive infrared sensor, we can create a distance measurement, or the distance kind of measuring a distance kind of application. But the and we can use this. I think there was a network disturbance. Is my voice clear?
Yes,
Yes,
sir.
Hello?
sir. Yes,
Okay.
sir.
So on the PIR sensor, I'll again repeat. I think there was a lag. So on the PIR sensor, we can implement a distance measuring equipment, or we can integrate distance measuring code on with it. But the slight change in here is, this is working on a photo. It is working on the reflection kind of a what we can say working style. Means what, it is only working on with the heat signature. So if it is detecting a human heat signature or the human heat ratio, then only it is going to be triggered. So this is very well for the motion detectors, or if we are dealing with the high sensitivity area, it will give you a proper and accurate result. But whereas where we are using ultrasonic sensor, these are emitting only the sound waves. So any obstacle which is coming, which is a live obstacle, or any non-living obstacle, though it is taking up the reading. So this is generally used for parking sensors or the sensing activity. Like in a drone also, I'm using a ultrasonic sensor to avoid the obstacles. So obstacle avoidance and resistance kind of a mechanism we can always create with the ultrasonic sensor, and we can always rely on the ultrasonic sensor to provide us a accurate result, because the accuracy what we can have in any of the ultrasonic sensor is very good than the PIR. But PIR is mostly used to detect human activities. So that's why you can see in a smart lighting environment, PIRs are used. So once you walk through on the corridor, and if there is a PIR sensing light is available, then once you pass that light, automatically that light's turned on, and when you passed that area, then automatically there is no movement is detected under the light. Automatically that light is switched off. So for this kind of application, PIR is perfectly used. Even PIR can be used for barricades as well. So if only the humans are passing to the gate, then automatically that gate will be open. Otherwise, it will remain closed for all the other things. So if the car is coming, then again that gate will not going to be open. So in that case, for the smart barricades, even taking a use case of fast tag, we always used to see at the toll gates. So now that is a debatable one, whether the fast tag is actually fast, and that they are having limitations as well. But if you can see on the technology front, what is a fast tag? It is a RFID tag only. Even the RFID reader what I'm having right now, it can read that fast tag. I have already tested on my car. But still, how exactly these fast tags are working? These fast tags are having a better resistance for the RF signals. Now better resistance for the RF signals means what? It can travel through a very good distance, because a normal RFID cards or NFC cards needs to be on the some certain level, or up to the 5 centimeters. But if you can see the fast tag, these are way far, and those readers are mounted on the tower or something, and they are reading the car's fast tag, so they are optimized in that way. But it is simple RFID communication. So in that way also you can create RFID communication for your own systems to pass on through the a particular gate or something. So you can create variety of security applications out of that. So whatever the sensor we want, we can just take it, drop it, and we can optimize it. So this is a tilt sensor what we are having. Then we are having gas sensor, we are having temperature sensor. Now this is not the DHT11, this is IMD36 sensor, but it will do a pretty good job. Then we can have a keypad, so if we wanted to create some application using keypad, like what password application, once you put your password, then only you'll get entry, or any kind of application. Then you can have a dip switch on and off. You can have a dip switch for 3 layer switch, you can have a 4, 5, 6. Even for the output layers you can have LEDs, different types of LEDs. You can have a multicolor LED as well. You can have a light bulb, neopixel. So the neopixel is what it is, a small output device which is having RGB LED. RGB is what? Red, green, blue. So red, green, blue LED, and you can program it. So these are the jewel, neopix ring. So these are the different orientation of different types of LEDs we can see. These are the LED strips. Then we can have a DC motors, we can have a micro servo motors, we can have a servo motors. It is best that we are having a micro servo and servo, because I'm also having a servo motor. So once we are dealing with the motors, DC motors, encoders and all that, there we can drag and drop and we can integrate it with it. Then for the power, we can have a 9-volt battery, we can have a 1.5-volt battery, we can have a coin cell, that is a CMOS battery. Even we can have a potato and lemon batteries as well, but we will be not using potato or lemon batteries. Then various types of breadboards we can have. So we can have long, short, or just mini kind of a breadboard. We can use it according to our requirement. And in the microcontroller, actually we are not getting that kind of choice. For the Arduino we are having only Arduino Uno R3, but for a limited use, because the simulator is for what? It is for the limited use. So for a limited use we can always use the Arduino R3. Even we are having microbit or microbit with breakout, but again microbit is having the same what we can say, microprocessor. So we'll be using a Arduino Uno. Then on the instrument side, we can have a multimeter, power supply, all these kind of functionality we are having. So always we are having with the different types of sensors, like and the ICs. So we can have timer IC, dual timer IC. So that way we can do. We can have a power control diode. We can have relays. Even we can have a motor controller, servo motor controller. Then we are having different types of connectors. Then we have logical sensors. So these are the typical hardware uh, what we can lab you used to see in your college. So these are the sensors what we can have. So what I'll do is I'll just remove all the sensors from here, and we'll do our first simulation project. So for this, what I'll do is I'll take, even you can search from here. So I'll take Arduino Uno, and even if you can see over here, these are the starters, right? So if I take this one, I'll just, now this is what, this is a LED blink program. So they are having a one LED with the power, and it is, there is one resistor installed. Resistor capacity is 220 ohm. So this is a resistor to regulate the power. So once I simulate this, so for simulating this, I need to click on the Uno, and then I need to click on start simulation. Now what this simulator will do, the simulator will switch on the LED, switch off the LED, and it start blinking, right? If I click on start simulation, now you can see this LED is started blinking for 1 second. It is again turning off, turning on, turning off, turning on, and turning off. And the same thing, if you can see over here at the controller, this LED is also blinking. Now why? Because if you remember, I showed Arduino Uno, and I've explained the LTX RX at that time, that is the LED button. So this is the very first program of Arduino. Like if you wanted to test your Arduino whether it is functioning or not, you can run blink LED program. It is just like a hello world program. So let's do something, what we can say, useful for us. So let's do it. I need to stop the simulation to in order to move this. So for moving this, I need to select entire. Then now how you can select the entire sketch, you need to click on the blank area, and then hold your click, and then you need to hover the mouse. So I'll put my simulation here. I'll use Arduino again. I'll take it over here. Then I'll use PIR sensor. So what we will be doing is we will be creating one motion detector program. So in order to connect your our PIR with Uno, uh, we need to click on the pins of the PIR. So this is what the signal pin is. So if you hover your mouse, it will show you what pin it is. Like we need to see in our sensor the codes and the printed circuit, whether which pin is for what. So similarly here they will be displaying. So this is a signal pin. So the signal pin will go to 3. So if you click on that, automatically wire is attached to it. So then again we need to create our what we can say, our circuit very neat and clean, so we can use like this. So once you click here, just click again, it will turn your wire, then you can have it according to your requirement. So I'll put it to the 2. I'll be using 2. So this my wire is getting connected. Then power, my PIR will require 5 volts. I'll be putting this to 5 volt. Here it is the 5 volt. So yeah, I've not done it properly. Okay, fine. And then the ground will go to ground. I'll just click somewhere else. I'll be not that creative here. And then here is a ground. So once it is connected, now we need to program it. Now it is not like that it is connected, that work is done. We need to program it like we are programming our Arduino. So if you click on the Arduino, then you will be getting the option of code. So here you will be getting 3 types of a code. One you can create with the blocks. So this is a very easy way or the convenient way to program. But again, if you wanted to play with the text, then it is not that feasible for us. So firstly, we'll go with the text. Once you click on the text, this is a general what we can say, our editor like we see. And then we are having our program ready, that I'll just copy. Yes, so this is my motion sensor program. I'll just copy it here. Now what this motion sensor is doing, now this motion sensor needs to be calibrated in the environment, because I'll show you the motion sensor first, and then we'll move with the actual program. I'll just turn on my camera. Okay, so this is the motion sensor, this exact motion sensor what we have connected on the simulator. So it is having again 3 pins. These are the 3 pins. The first pin is here. The first pin, this one is VCC. Middle one is a signal, and last one is ground. So it is slightly changed in the simulation. Now you can verify it from here. You can see VCC, out, and ground. Out means the signal pin, and this is the actual sensor. Now this sensor will emit infrared signal. Once this infrared signal is obstructed by, or it is what we can say, reflected by a human, I'm just hovering my mouse or hovering my hand over here. So once it is reflected, now here is a dome. It is collected through the various honey pots, like you can see over here, honeycombs, and it is directly pointed to the center of the sensor. So once it is pointed to the center of the sensor, then it will start recording it. Then we can have a potentiometer over here. So through potentiometer we can adjust its distance, and we can adjust its sensitivity. Means distance means the tolerance, we can see. So this one is for the tolerance, and this one is for the your sensitivity. The more sensitive it is, more it will capture, and the more timer it will have, means the tolerance it will have, the most it will trigger the event frequently. Like if it is set it to a high timer, then it will hold your lights on, or whatever the application you have turned on, that is for the 7 minutes. So for this sensor it is for the 7 minute. So we can have a better PIR sensors which can have larger timeout or timing, or even we can have this jumper setting. So this jumper setting is set it for a one interval only. So it will detect a motion, it will hold that motion, it will hold that degree, like turn on a fan or turn off the fan, whatever that sequence is, for a 7 minutes maximum, and for a 7 seconds minimum, or 1 second minimum actually. Then if you wanted to put it into a repetitive cycle, so we wanted to make it in a loop, then we need to remove this jumper and place it to the next 2 pin. Now this is into a repetitive mode. So what it will do is, it will sense a motion, it will start a counter. Once that counter reaches to the end, then it will stop, and again it will start a counter, and it is in a loop. That light will remain on until you turned off it manually. That way we can actually perform this. So similarly we can do over here, or we can detect the motion. Let me take it in our simulator. So this is the code for it. Now this sensor needs to be calibrated in an environment to sense whether what things are there, whether there is a human or not, and everything. That is the calibration time. So we are given a calibration time for a 10 seconds, and then we are having a detection. So once this code is done, you need to click on start simulating. So once I'm clicking on the start simulating, here is a serial monitor. Now you can see over here, calibration sensor is done, and now my sensor is ready. So what I will be doing is, I'll just stop the simulation. I'll bring this here so we can see it properly. Okay. So I'll again start it. Now you can see calibrating sensor, it is done, sensor is activated. Here is a timer. Then once I move around here, then it's supposed to detect the motion. But now as it is a simulator, how we can move? So we need to click over here, then it will show us a proximity. So this is a 180-degree angle. I'll just zoom out so you can see. Yeah, so this is a 180-degree angle. So it will sense the motion in this 180-degree angle. So this is a illustrated human. So if I click on this, it is start blowing, and it is showing that sensitivity, or it is showing that there is a motion which is detected, but it is not showing at my code, maybe because of the uh, low latency what I'm having. What I'll do is, I'll just stop this, I'll clear everything, I will start it again. It has to be calibrated. Oh yes, why it is doing this? because I have setted PIR pin for 3 and I've connected PIR pin to 2 pin, second pin of the, so the second pin of the Uno. So what I will need to do is I need to change it to the third one. Oh, I need to stop the simulation first, sorry. And I'll put it to the second. I'll delete this. I'll delete this one as well. I'll take the third one. It is more easy in the actual one. Okay. Now I'll start simulating. Now our simulator is done with the calibration. Here is the sensor, and if I move a bit, see, once I am moving, it is showing motion detected at 4 seconds. So once it is recalibrated, again it will define the distance, right? So this is how the simulator is working. Now let's see the same thing in action with the actual board. Right, so let me take out my board first and some jumper cables. Let me turn on my camera so you all can see. I'll just bring it to, okay, so I'm doing the same. Now I've interfaced it. I'll just see which is a VCC. VCC is red, so VCC will go to 5 volt. When ground and when ground and this is a 5 volt. Then middle will go, this is the out, which will go to 3, and finally 1 is to ground. This is our circuit done. I'll just program it. Where is my, just a moment. Where is my cable? Here it is. I'm just programming it. The same code what we just added to the simulator. It is having LED calibration time is 10 seconds, LED PIR pin to the 3. I'll just upload it. Is my screen visible?
Yes,
If we,
sir.
so if you can see now, calibration sensor done. Now this is a serial monitor of our IDE, and it is started taking up the motion. So I'm just moving my hand. It is saying the motion detected at 1 second and motion end at a 1 second. So I'm just putting up the hand again, and I'm removing it. So it is not in a loop. That's why it is we're waiting for a larger timeout. Let me check whether it is in a loop or not. Yeah, it is for the 1 milliseconds. Okay, fine. So it is recalibrating it, motion detected at 1 second, and then it will turn off. So this is the actual implementation. So in a simulation also we can get a pretty good results, but unfortunately all the sensors are not available in simulation mode, but maybe in some another simulator they will be. But I found Thinkercad quite good and neat and clean for circuits. Now even here also the simulation was up. Motion detected at 3 seconds, and then it stops. It's working. Yes. So are we clear till this point? Are we clear how to use simulators or how to use Tinkercad? Any question, any doubt in this? So I think
So
that
I think
No, sir.
okay, great.
okay, great.
So
Sir,
what
is
we'll do is
Raspberry
we'll
Pi
take a lunch break,
there in
and
Tinkercad?
then
Sir,
we'll move to the another session.
sir, is
Yes,
Raspberry Pi also there in Tinkercad?
Raspberry Pi.
It's also is available in Tinkercad.
For the Thinkercad, no,
No.
actually, Raspberry Pi is not available with the Thinkercad. What I'll do is I'll check out with the another
Mhm.
simulator for Raspberry Pi and let you know.
Okay, thank you.
Hello, sir.
Okay, so thank you. We'll see you in next session. We'll take a break now.